It is our first seminar, and we will get acquainted with neural network basics. So, we will need PyTorch. It is framework for machine learning realized in Python language. NumPy, numeric Python. It allows us to calculate metrics, etc. And matplotlib pyplot. This will visualize our data. So let's import these models. Here it is. So the first function is tensor, torch.tensor. It creates a tensor, respectively. You can see the returning value. Okay, and torch zeros create a tensor 2, but a tensor of zeros with 2 rows and 4 columns. We can work on different devices. That's why it is need to specialize them. For example, you can choose device in runtime. Yes, change runtime type. And here you have CPU, TPU, and GPU. Let's work with CPU. Okay. Here we can see device, and if Torch CUDA is available, we will work in GPU. So for us it is disabled, so we will work at CPU. Then we will create a tensor of ones with 2 rows and 4 columns. We will specify the type of these numbers. It will be a float 64 bits it will contain, and device will be a CPU. Okay, here we can see the result. Let's move to the operations with tensors. Let's create tensor X and tensor Y. Nice. So we can get the sum of tensor X. It will be 1 plus 2 plus 3 plus 4. It equals to 10. Nice. But this function returns a tensor of the sum. If we want a number itself, we need a method item. Here it is. Yes, we return 0 because the sum of tensor y is 1 minus 1 minus 1 plus 1, 0, respectively. Okay, what's more, we can add one tensor to another. Here we have an answer. How it is going here? 1 plus 1, then 2 minus 1, 3 minus 1, and 4 plus 1 equals to 5, respectively. What's more, we can multiply in one tensor with the another. Let's look at the result of this operation. Okay, we will return 1, minus 2, minus 3, and 4. Here it is. Then we can use matrix multiplying. How does it work? We need 2 tensors. The first one will be with the random value, torch rand, and the second one will be a tensor 1, minus 1, and 1. But we will transpose it because when you multiply in matrix vectors, the first should be a row and the second should be a column. Okay, let's look at the result. Here it is. Okay, and let's get an item. You see, here's an item without tensor. And the last method, concatenating. Our weights are here, these three numbers, and the number 1.5 will be added to this tensor. Let's look at it. And the second argument is the position of adding number. Here it is 0, that's why it is adding at the end. Let's recall to the neuron model from the last lecture and realize threshold function. How does it work? If the signal is more than a certain threshold, it returns 1. In another case, it returns 0. Here it is, and this is the realization of this method. Let's look at this threshold function. Nice. Here it is. If the signal is less than 0, we have a 0. In another case, we have 1. Okay, for working with neurons, we need to create class, yes? And write functions that are contained in neurons model. Okay, in method init, we will have an input shape, weights, and activation function. Okay, and debugging flag, which will print all the information when we will need it. Okay, in method init, we take weights. If they are not in the arguments, if there is no weights in arguments, they will be randomized. Activation function and flag debugging. Let's go to the aggregate signal. How does it work? At first, we will multiply weights and input tensor. We will take the item of the sum, and after activation function, we will return output. But here there is no activation function, as you can see. Activation is here. So we take another argument, input value, and apply activation function to it. In the end, we returns output. And here it is the method, the basic method of framework PyTorch. Here you can see a list of operations that will be applied to your input tensor. Okay, let's do it. Nice. Let's go to the first example of this class working. This will create our dataset. Here you can see two classes of points, red one and blue one. And we need to divide it. We need to find a line which will approximate the boundary between these two classes of points. Let's take one neuron with value with input shape. Yeah, here it is, input shape. So we will take omega 1 and omega 2. After this, we will take some random numbers for plotting the graphic of this line that we want to approximate. So let's do it. Here we are. This line is approximated the boundary between these classes. Okay, nice. Let's use our neuron. Okay, our weights will be -1 and 1 respectively. They are returned from this system of equations. Here is a coefficient of a linear function, our line, that divide our data. Okay, here we are. We will create an object of our class neuron, and if out of the function forward will be more than half 0 and 0.5, it will be the red point. Yes, we will draw the red point. And in another case, we will draw the blue point. Okay, let's look how it works. Okay, here is a lot of information because we take debugging flag true. Okay, and here it is. The point with coordinates 0 and 1 is red one. And it is true, yes? We can see it in this graphic. Okay, let's move on. Bias. As I have already said in the last lecture, bias is a free input and it doesn't depend on the input signal. So let's create our dataset. Look at it. Okay. Here you can see that the line will be upper than that one, and it doesn't contain the point with coordinates 0 and 0. So this is the reason to apply bias. Let's take our weights and approximate this line. So we have selected our weights. We have a list of coordinates for our line. So as you can see, this line can't divide our classes correctly. And the main problem is that it should contain the point with coordinates 0 and 0. So we need to refuse it. And here we have a solution to this problem. Let's add bias. And after that, our equation of coefficient k and x1 will be here. We are using bias in this case, and we should rewrite our basic class, neuron. We will rewrite it with the new name, bias neuron. It will be inherited from class neuron, and the main difference will be here in forward function. Output will add self.bias. You see? Okay, let's do it. Nice. And now, from these equations, we can select right bias for this task. Let's do it. Nice. The correct line is got. After this, we will use our new class, bias neuron, with weights and bias that were calculated in the previous block. Here. So here. Yeah. And let's look how our neuron works. If output more than 0.5, this point with coordinates 0 and 1 will be red, and in another case it will be blue. Okay, nice, it is blue, and it should be blue, so this model works correctly. Let's go further. There are some operators such as AND, OR, and XOR. So they are described in truth table. Here we can see a truth table for operator AND. The combination of 0 and 0 gives us 0. The combinations of 1 and 0 and 1 and 0 gives us 0, and combinations of 1 and 1 gives us 1. Okay, here you can see the operator OR, how it works, and here there is an operator called XOR. It differs from this one, and we will use this operator. Let's generate our new dataset, data sample. And you see that here we have red points in the middle of an area and blue ones in the sides of this area. So we cannot divide this data with one line, yes? Because if we will draw it here, okay, this area will be for blue points, but this will be for red, and it's incorrect. So we need to take not only one line, we need to approximate two lines here. How we will do it? So let's look at this. If the line is here, it's incorrect, and line is here, it's incorrect too. So that's why we need a new class which will generate not only one neuron. We need a class which will generate a combination of neurons. It represents the neural network. You see, in init method we have two lists. The first one, first layer, and the second one, second layer. In function forward, we at first looking at the neurons in the first layer, and after that we are looking at the neurons in the second layer, and the returns our output. Okay, let's look how it may work. Here you can see a picture which show you that one neuron cannot find a solution to this problem. That's why we will use our new class that is called perceptron. Okay, nice. What we are doing here? We create an object of class perceptron. After that, we define our weights and bias. Then we are creating the bias neuron and append it to the first layer of our perceptron. Then we selecting weights and bias for the second neuron and append it to the first layer too. And after that, we are creating our weights and bias for the neuron that will be appended to the second layer. You see? Okay, nice. We have created a structure of simple perceptron. Let's look what it can do. We are looking at results, yes? We are looking at returns values of this model. So the points for which the output is bigger than 0 and 1 are red, and in another case they are blue. And here we are. Two lines give us a solution to this problem, because this line represents the boundary between reds and blue, and this line do the same task but in the different area. So with using of this method, we can find a solution to this problem. It shows you how perceptrons are working. So that's all I wanted to say. Goodbye.